Good afternoon, everyone. Our thesis topic is greening building blocks to mitigate heat. It's a design research in residential areas of Rotterdam. In the presentation, we will introduce our research objectives, research questions, result of our theoretical study, and design principles. Next is how we apply the design principles in site design. After that, we will have conclusion and recommendations. Urban heat island brings about serious problems, and most importantly, it increases the vulnerability of human body. Building density and building height-to-weight ratio influence wind and sun radiation in cities, and thus influence the UHI effect. So, certain building configuration types are more likely to accumulate heat than others. Green is regarded as one of the most efficient tools to mitigate heat, mainly through shading, evapotranspiration, and wind channeling. We chose Rotterdam as research area where the expanding urbanization process causes and intensifies heat accumulation. We focus on the residential areas because it's most related to people's everyday life. Our working scale is building scale. It contains buildings and entire space such as backyards, playing fields, public car parks, and green space. Objective of this research is to identify residential building types that tend to accumulate heat and use green to mitigate heat. Firstly, through literature review, we concluded cooling effects of green on building scale, including green surrounding buildings, small green fields, green facade and roof, and green parking. Here, this is our green toolbox version 1. Then by overlapping 3 heat maps and compared with land use map of Rotterdam, we located residential areas that tend to accumulate heat. By zooming into each hotspot, we collected 113 sample building blocks that tend to accumulate heat. We analyzed the block in aspects that relate to heat accumulation. For example, the orientation, building height-to-weight ratio, and current green situation. Using parameters from Pons and Hobbs research on building density and categorization, we categorized all these samples into 8 types. We quantified each building configuration type and found that low-rise building block type, hybrid mid-rise stripe or block type, and mid-rise block type are most likely to accumulate heat. We named them TAH building configurations. We generated 7 templates on the basis of these 3 main types. Using Green Toolbox 1 and our creativity, we generated green design principles for the 7 templates. Today, we will take mid-rise block with public backyard and different roof heights as example. We defined features of the template according to features in samples, including roof types, facade forms, backyards, and so forth. Current green situation is normally poor, so we only look at the buildings and then use green at needed place. We illustrated wind condition both in summer and winter. It turns out that wind problems occur in form of corner streams and poor ventilation. Air filtration and humidification is needed. We selected guidelines from Toolbox version 1. We developed them further and proposed to have clusters of trees to shift corner streams, green pergolas at eastern gaps to moisturize the coming wind. Inside the block, tall evergreens deflect winds at southwestern entrances. Loosened deciduous shrubs filtrate and moisturize the wind at northeastern entrance. We simulated the shadow pattern in June and December and conclude that in summer, southern facade, roof, and this part of the backyard needs shading all day and thus have priority in shading. Inner facade facing west and southeast part of the backyard needs shading in the afternoon. Inner facade facing east and southwest part of the backyard needs shading in the morning. We selected guidelines from Toolbox version 1 and used under a green roof. Indoor temperature was found to be at least 3 to 4 degrees lower than hot outdoor temperature. We proposed to have extensive green roofs on tall buildings intensive green roofs on lower flat roofs so as to reduce temperature also at pedestrian level and reduce radiation reflection to the surroundings. Currently, these two are the vertical green with reliable cooling effects and growing condition, wall vegetation where plants grow by clipping to the wall, and green or greened facade. Supporting system or pots on the wall is needed. In our case, we only use them to green the facades. We propose different solutions for different facade types. Vertical supporting system and planting boxes are both used to help plants grow vertically and horizontally. Inside the block, larger sized plants can be grown from the floor. Vertical green in public balconies need to be easily maintained and massively managed. In both cases here, plants can be irrigated with rainwater. Vertical green in private space need to be easily customized according to user's wish. Windows and private balconies can be shaded with this green awning system. In winter, it can be put upward and let sunshine into the room. Public backyard is larger in size and thus offers more possibilities. Residents can have neighborhood gardens such as vegetable garden and leisure garden. Small parking lots and centralized parking for several blocks can be placed. On the whole, green interventions for mid-rise block with different roof heights and public backyard are here on roofs, facade, inside and outside the backyard. Following the same way we gave green intervention suggestions for all the 7 templates. We further reorganized the principles according to aspects green interventions can be applied, including roofs, facade, front garden, backyard, and so forth. We chose 2 sites to test the design principles. We will introduce the one in Berkholder South today, and it corresponds to mid-rise block with public backyard and different roof heights. We firstly identified the problems concerning functionality of the site, and then simulated the shadow pattern and wind condition of the block. In this way, we located shading needs of different areas and wind problems. From Green Matrix 1, we get the design principles. We propose the site plan here. New design for the frontal plaza, the roof garden, and southern facade can be equipped with green. Besides design principles from its template, potential areas of the block are assigned with principles of similar aspects or from reference templates. In northern parts of the frontal plaza, small deciduous trees with low trunk are provide morning shading without blocking too much sunshine in winter. All-day shading is realized with green pergolas. Deciduous trees with wide crowns and dense leaves are planted in the west to provide best shading after 12 o'clock. At southern part of the plaza, current species is of narrow crown. We suggest using deciduous trees with wide crown to provide shading all day. Quiet area in front of the plaza is for short stay. Green bicycle parking is connected to the benches, and pergola on the bench can provide shading to both people and bicycles. In southern and middle part of the roof garden, deciduous trees with dense leaves are planted to provide shading all day. In the northern part, the area is reserved for winter activities. Small pergolas can provide shading in summer. We designed this area to be a vegetable garden so that the ground can still be shaded. Ground plantation wells helps reduce weight load of the roof and provide better growing condition for plants. Here is a view towards the vegetable garden. Both shaded area and sunny area are provided. Here is the recommendation for southeastern facade and for southwestern facade. We simulated the shadow pattern of frontal plaza and roof garden to make sure that sufficient shading is provided in summer. while sunshine isn't blocked that much in winter. In wind condition simulation, we can see that at the entrances and where people stay, corner streams and unpleasant wind are shifted away. Now we come to our conclusions. Major outcome of this thesis is, firstly, the 7 representative templates of residential buildings that tend to accumulate heat. Second is the green matrix. Through simply comparing the blocks at the site with the template, designers can quickly identify problems concerning heat accumulation and thermal comfort at site and adopt corresponding solutions. Our recommendations are: the 7 TAH templates can be used as medium for more cooling interventions. For example, green design can be combined with water. Secondly, streets and buildings can be studied as a whole entity. Thirdly, our methodology can be applied in studying other land use types and also in other cities. Fourth, we hope that research can be more assisted with simulation and measuring techniques, and then design can be evaluated both qualitatively and quantitatively. That's all for our presentation. Thank you very much for your time.